great to see so many familiar faces and some new faces. I am a longtime member of the club. As my bio mentions, I got started here at the museum as an astronomer, well as an astronomy educator. I'm not an astronomer, I'm an astronomy educator. This June marks my 25th anniversary here at the museum. So that's an exciting milestone for me. I am, as the Baron mentioned, I'm a mom, so that's why I'm not at a lot of the meetings. I come when I can, but I have young kids. It's prime time with them. They won't be young forever. I'll be back. I have 3 kids there, 7, 9, and 12. Perfect ages. So says you. Come to my house. Well, I actually had to leave a soccer game early to be here.
Oh.
They were getting creamed. So it might have been better that way. I will admit I'm a little bit intimidated to be speaking today because I know so many of you. I know just how knowledgeable you are. So I'm prepared, but if you ask a question and I don't know the answer, I will be embarrassed but not surprised. I'll do my very best for you. But this one, I give a lot of talks and presentations, and this one is I was stressing this one more than most of them because I don't want to let any of you down, and I also just know how knowledgeable you are. So we'll just do our best. I do want to put in, I'll update you right at the beginning of the talk about the Girl Scout Astronomy Club. I was contacted last spring by the local Girl Scout Council. They wanted to apply for this program that NASA funded to have Girl Scout councils form an astronomy club. And they needed an astronomy advisor, so they got in touch with Chuck, who bounced it over to me, and of course I said, girls doing astronomy? Yes! Let's do it! So they applied, and out of the entire country, they were one of only 10 councils chosen. I know. So I flew out to Goddard Space Flight Center with 2 high school students who are Girl Scouts, who are the club leaders. And we got a week of training, and then they came back here, and they met with the AU leadership at a planning meeting, and we formed this great partnership, and it has been hugely successful. A lot of the astronomy clubs that are already formed, these other clubs, you know, there's the 9, they say things like, we had 7 people at our last meeting, it was amazing. Well, if you've come by to any of our, we fill this hall. Part of it is because they have to have their parents drive them, so instead of 1, you get 2 or 3. But we're getting at least 30 Girl Scouts at our meetings, which is so great. It's fantastic. And a lot of them are young, which means if they stay with the club, they'll be there for a really long time and they'll learn a lot. They come every other Star Party night to have a lecture here, and then they have a telescope NASA bought them, and they take their telescope out to the Star Party, so that's been really fun for them. They have a workshop coming up. The main reason I'm mentioning is this. I got an email today from the Astronomical Society of the Pacific saying, we are having a free symposium for any amateur astronomers that want to learn more about the program and maybe get trained on some of the astronomy badges. It's free, come on up to Oakland. So if you would like to come on up to Oakland for a 2-day symposium that is free, they will provide you free lodging at the SBAU Science Center. That is March 21st and 22nd. And if you're interested in that, you can let me know. But they're putting a lot of resources out there for these clubs to support them. And I'd say our club is doing a really great job of taking full advantage. So it's going really well, and I cannot thank you enough for all of your support. The girls feel just really appreciated and valued and supported by everyone in the AU. And it makes so much of a difference to them to feel like they're not orphaned out there alone. To feel like they have you behind them really means so much to them at our planning meetings. They speak so fondly of how kind you are to them, and so thank you for that.
Thank you for your service.
It is entirely my pleasure and slightly self-serving now that I have 2 Girl Scouts. Okay, let's talk about Mars. Ooh-wee, there's so much to talk about. People have been talking about Mars for a really long time. So in this picture, you see that little tiny dot? That's Mars. That's the way you see Mars if you went outside to look at Mars. And for millennia, that's what we saw of Mars. Sometimes slightly bigger and brighter, sometimes slightly smaller and dimmer. That's it, that little dot.
Where?
Then you get out the laser pointer, it'll be like 20 times brighter. We don't actually need to turn off all the lights for this one.
No, turn out the front one.
Just the ones on the screen.
Well,
Yeah, perfect.
I'll make it a little bigger. This is Mars through telescope. All right. Doing better, right? As soon as Galileo built one, we could see a little bit better. And then we started building better telescopes. And then it was this guy. Then we started mapping Mars. We've been fascinated with Mars for quite some time. Of course, this is one of Schiaparelli's maps of all the canali on Mars, infamously mistranslated from a natural term of channels created by water to canals, man-made waterways. That's not what our talk is on, but it's part of the history. And as soon as we had the technology to do it, we started trying to send stuff to Mars. So we won't dwell on this, but this is every robotic mission we've tried to send to Mars.
Wow.
The ones with the X's are the ones that didn't go so well. So if you see all these like little red X's, boo, 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 didn't make it. Oh gosh, there's so many of them. The lines, the colored lines indicate the nation of origin, right? So the United States is this blue one that has a lot of green check marks, and Russia / the USSR has the red ones with a lot of X's. There's some in between. We've had our fair share of X's, to be fair. Remember the Mars Polar Lander? Anyway.
Who are the orange ones?
Let's see, the orange one, so the orange lines right here.
No, that's, or the yellow ones, I should say.
Way down
There's two of them that end up.
Oh, this one right here, and this one right here?
Yeah.
So that's Russia.
Oh.
Yeah,
Post-Soviet Union.
exactly. India has actually had a pretty successful track record thus far. We'll see how they do. We'll talk about that later. But they're 100% right now. Yeah, highest batting average. So we sent a lot of robots to Mars. As you can see, some of them are rovers. Anything that's on this line, this is a rover. These are landers that are not mobile, right? If it can't move around, if it just sits in one spot, then it's a lander. A lot of orbiters. So many orbiters. Flybys. And a lot of stuff that didn't make it. The more modern and some of the best known missions include the very first one, the first lander on Mars was the Venera. Obviously you can see from the Cyrillic characters there that is the USSR. Is that a question?
Yeah, that's Venus.
Oh, you're right. That is Venus, the Venus lander, Venera. Viking, this is Mars. Thank you. The Venera lasted a matter of hours on Venus, but it landed. We haven't gone back. It's not very hospitable. We like Mars better, right? And then there was a long time when we didn't do much landing on Mars, and then suddenly we were back in the 90s. Now we're getting the stuff I remember. I was working here as a high school student, and well, by 1997 I was a college student, working here in the planetarium, telling people all about the Mars rover. The Sojourner was so cool. People were real excited about it because it was so cute driving around Mars. And of course, the technology was so much better. We were getting these great full color images and a lot more data. So this was a landmark on Mars, this rock. You would really have to find out, except for the rover still over there, called Yogi.
It's like the art of JPL.
Yogi.
No, that's on.
Yogi the bear?
My notes go. Let me see what happened. I'm gonna check for my notes here. We're good. I just want to make sure I'm not calling Venus Mars anymore. Okay, good. And then in 2003 it launched. 2004, the Mars exploration rovers landed on Mars, and I know some of you were here with me when we had a really big museum-wide, we had two of them. When the first rover landed, we had this exciting Learn About Mars Day, and then everyone said, wait, something landed on Mars, you should have done an event. And we said, we did. Luckily there was another one landing 3 weeks later, so we did it again. And that second one was far more popular, hundreds of people came. The 3D glasses were real big, right? Because the mast on the rovers had stereoscopic cameras. So you could look at Mars in 3D. And again, better technology, lots more images, high resolution, and by then the internet made it so that everybody could be accessing all of these images in real time. Yeah.
What are the dimensions of this Sojourner and the Spirit of these?
Oh, great question.
Well,
So the Sojourner was pretty small, like fit it, you could cradle it like a heavy baby. These are more like a golf cart. Yeah. So like a golf cart size each, approximately. They are not still going, but almost still going. The first one, Spirit, so they arrived in 2004, and it was supposed to be a 90-day mission for each one of them. So Spirit went until 2010, and Opportunity just hit the bucket last year. Stopped sending signals in June. They tried to hail it all several months, waited for it to wake up, went into emergency mode, battery shut down, wouldn't recharge, and eventually they had to call it. But I would say that, 15 years is pretty good for a 90-day mission. Traveled all over Mars, both of them. When I say that, I make it sound, like they didn't actually travel that far, relatively speaking, right? When we think about traveling far on Earth, like in our station wagon, we get a lot further. They don't have much of a cruising velocity, and they spent a long time studying. But they made some pretty specialty opportunities, all those extra gears, crater all around. Covered some really interesting places, and wow, sent back so much data. The Martian blueberries are one of the most exciting stories that came out of that. I'm gonna move on because we're talking about like future Mars, but I think it's so exciting. I keep talking about it for days. The Curiosity rover, that was the next one. Curiosity is like a small car size. This was also known as the Mars Science Lab, MSL, excuse me. People sometimes still refer to it as that Curiosity, and it's still going. Still sending data, doing lots of stuff. It has had some issues with its wheels that have made sure that engineers have redesigned the wheels for the Mars 2020 rover. So that was an important data point that came out of that one. So Curiosity is there now still. And then, of course, Mars Insight. Launched from Vandenberg. Anybody watch it launch? I did. I got up real early, drove up West Camino Cielo to see the launch. I had a much better view than all those people in Longboat because it's really foggy. So it was exciting. It's not a rover, it's a lander, but it's been in the news lately because of this. It's called the mole. This thing right here it's a self-hammering drill. They're trying to get to go down several meters, about 3 meters or so subsurface, and it has temperature probes that go all along the arm. So they like to, NASA likes to get all cutesy with it. And we're taking Mars temperature. Yes, like a thermometer, stick it really nice and deep, see what's happening. But the arm is having a really difficult time. They stuck it in and it went a little, and then it's in like, a few inches, and it kind of stopped. And so it turns out that what's happening is that the soil on Mars, at least where Insight is, it's kind of slippery. There's not enough friction for the hammer to get any purchase as it's drilling down. So it's been kind of stuck, and they've tried all these different techniques, and they have a couple new ideas that they hope will work. So I have this quick little video, just a few days old. And the scientists from NASA are going to tell us what their plan is.
I'm Architect Treviolino, and I'm the Instrument Deployment System lead for the Insight Mars lander. And as you will recall, we had a problem or an anomaly with the heat probe. After deploying it, the mole stopped penetrating, and the robotic arm and the instrument deployment system has been helping to investigate this anomaly. So this is how we've been using the scoop to help with the mole. There's a big hole around the mole, and we've been trying to use the scoop to collapse the hole. We've been using the back of the scoop to push on the hole to collapse it. We've also used the tip of the scoop to try to collapse the hole multiple times, but we've been unsuccessful. Our next attempt is to constrain the motion of the mole by pinning it to the one side of the wall. By doing that, we believe we will constrain the motion of the mole more in the direction downward, so we might make forward progress. Here's another idea. We would use the scoop to scrape the soil to fill the hole around the mole. Then we will use the back of the scoop to compact the soil around the hole. Then we'll go back and pin the ball with the scoop. And we believe this will significantly reduce the sideways motion of the ball whilst it's hammering. As you can see, this is a very, very challenging problem. And sometimes it appears intractable, but we're engineers and we love solving challenging problems. We're cautiously optimistic that one day we'll get the ball working again.
So we'll see, that's the next plan. Fill in the space that it's already dug in, they can't get past, because it's just slippery and stuff. And then, hopefully, by adding some extra pressure and packing in that soil a little more, it'll be able to dig down further. In other Insight news, I didn't put in the presentation because it's 1.8 billion pixels, and it's really much more fun to see on your own. But it did release this super cool, really high-res image that was several exposures, lots of exposures, stacked on top of each other. That has just, the detail is incredible. And I don't want to like pull it up and navigate and zoom in and out because that's kind of vomit inducing when someone else navigates that for you. But if you are so inclined, just Google Mars Insight image. You can even just probably Google 1.8 billion pixels and it will just pop right up. Yeah.
Isn't using that mole using a lot of electricity and draining the battery and messing with that mole is gonna make this mission a disaster?
Well, hopefully not. And the batteries, as far as I know, are still in okay shape. No one's, it's got a solar battery, so it should be okay for now. Hopefully the whole situation, I think they're kind of running out of ideas. And I'm not sure how many other backup plans they're gonna have after this before they just give up on that one.
All they're looking for is temperature?
Yes, but they're trying to look at subsurface temperature, not, because they have a lot of surface temperature, but they want to know what's happening subsurface. You know, like, they're looking for temperature variations, geologic activity, stuff like that.
But not what's down there.
No, it's not looking at anything.
Oh.
Wouldn't it be great if there were a mission that did that? Oh, let's go. Let's talk about it. So glad you mentioned it. So here are all the operational missions from 2001, all the operational missions of this century. Feels cool to say, right? So this is where we are, obviously, right now, 2020. Several different missions, not just NASA missions. And then this one is a maybe. When they made this graphic, it was like, yeah, this is happening now. It's not. We'll talk about all the future ones later, but beyond 2020 looks different than this graphic. So the overall goal of all these Mars missions has shifted over time. Obviously, prepare for future urban explorers is sort of the underlying one. The ultimate goal is get people to Mars and maybe they can live there. We'll see. And at first it was looking at, was Schiaparelli right? Was there water on the planet? And it sure looks like it. Can we find it? Is there any liquid water still there? And then things sort of shifted to well, we know there was water. We're pretty sure there was water on Mars. And then with some of the orbiters, we found out there's definitely water on Mars, but it's frozen in the soil. So now we know there's water on Mars. What do we do to take the next step? So that's exploring habitability. And then seek signs for life. They are not trying to find living Martians. That means they're looking for possible evidence of ancient, now extinct Martian life, probably microbial. But if there was liquid water on Mars, the hypothesis is maybe there was life there. So far, has been no conclusive evidence of that at this time. We keep looking. We're so desperate to find it. But so far, nothing. So, just named yesterday, the Perseverance rover. The mission is called Mars 2020, but they'll call the rover Perseverance. It just got its name from a naming contest that some of my fellow solar system ambassadors got to help judge. A 7th grader named Alexander Mather picked this name, and he gave this real cute speech. I thought about putting up the video, but there's so many other things to talk about. Real cute speech about, the one thing that has us keep going is our perseverance. Our missions sometimes fail and sometimes succeed, but we just keep going, and that's the one thing that makes humanity, different and better and special. So they picked that name. That's the name of the rover. Obviously, this is not a photo of the rover on Mars because it hasn't launched yet, but we can kind of see what it looks like. It has a robotic arm, mast coming up. We'll talk about all the parts.
What's the dimensions of the passenger?
Oh, so this one is like a car, like sedan size, like,
It's in that helicopter.
yeah.
Yeah, it's in the helicopter.
Yeah, we're gonna talk about the helicopter, I promise. I got a video about the helicopter. So first of all, when we were looking at, if we go back a couple slides, you notice a lot of these are like spaced about every 2 years out. Mars missions launch approximately 26 months apart because, I know this looks like the moon, but it's supposed to be Earth, okay? So here's the Earth's orbit and here's Mars' orbit. If you have to get a spacecraft from one to the other, you want to go the shortest possible distance. So they line up in a way that makes them close together approximately every 26 months. So right now, we'll talk about some of these other future missions, but the ExoMars mission that the European Space Agency is trying to launch has been having problems with the parachute, and if they can't resolve it, they gotta scrub it for 2 more years, they gotta wait. Because it's not, they don't have the support to have enough fuel and enough trajectory to get it to launch a farther distance. It's much more efficient to launch in that every 26 month cycle. So that's why that happens. See, it looks almost, all right. So mission objectives, 4-fold objectives. Geology, they are trying to, like I said, they're trying to study prehistoric Mars, not like looking for little green men or even little green microbes. They're trying to understand the geologic formations and how they changed over time on Mars. And then astrobiology, they are trying to see if Mars actually was at one point habitable, and then was there life, that's the second question. And then they are going to be taking samples. It's a potential sample return situation. We'll talk more about that, so that's exciting. And so yeah, so sampling, they're going to be collecting samples that they leave on the planet in hopes that in a future sample return, well, it'll have to be a pair of sample return missions. Like I said, we'll get back to that. We'll come and collect these caches of samples that they've taken. They're trying to take them from lots of different spots. They picked the landing spot to be very geologically diverse so that the rover can explore all these different regions and take all these different samples. So they're hoping to, it's supposed to last about 2 Martian years, that's the goal. 2 Martian, well, I think a year and a half Martian. They go back and forth. But anyway, that's like 3 to 4 Earth years. They're hoping to collect 20 different samples. They may get more than that if they extend past their prime mission. And then finally, prepare for humans, measuring all this different stuff. They have a tool on board that is going to be trying to convert the carbon dioxide in the atmosphere into oxygen. We'll talk about the MOXIE tool as we look at all this stuff. So that is not like the main target of the mission, but it's sort of like a proof of concept, I guess you could say. So, the launch date is, well, we'll just say the launch window begins July 17th, 2020. Obviously, anything launching out of Florida, I used to live there, I can tell you, the weather is iffy all summer long, hurricane season. But that's when the launch window starts. It will cruise for 7 months in space, and if launched in a timely manner, should arrive about February 18th, 2021. So, from an outreach perspective, people will start talking about it this July. It'll be exciting in July, and then they'll forget about it. And then get ready in February, because even though we're like, oh, we've been waiting 7 months, it's finally gonna get there, other people will suddenly become aware of it when their newsfeed like the day before is telling them about it, and then suddenly everyone in the world will be clamoring, oh my gosh, do we have a whole viewing party set? What's going on? How come the whole world hasn't planned for something I just heard about 2 hours ago? So, look forward to that in February. Happens every time there's a Mars landing. And entry, descent, and landing is similar to Curiosity. As you remember, the earlier rovers came down in these like big airbag-filled pyramids, and they just bounce on the surface and then unfold themselves. These larger rovers can't do that. They're too heavy, so they get lowered down, real gently onto the surface, sort of, kinda, hopefully, right? They deploy, there's a parachute that slows them down, and then a gantry that drops them. What's new with this one from Curiosity is a new system that is similar to the EDL system from the Mars Science Lab Curiosity, but this one has a range trigger and also TRN. That's terrain relative navigation. So I'll have a little video for that one. Whoa. So it'll have programmed into it, all the surface maps for the area where it's trying to land. Then it will take pictures of where it thinks it's landing, like, oh, well, I'm coming down here, it looks like this, compared to the maps. And then if it needs to make any sort of adjustment, because it realizes it's not coming down in an optimal spot, then it will re-navigate itself. If all works according to plan. I mean, there's a lot of ifs, and the fact is, they're actually trying to land in fairly treacherous terrain, like that's the point. That's really geologically interesting. So they're trying to land so that, you can see it's like on the rim of a crater here, right now. Yeah, they want to land like right on the edge of that crater. So we'll see how that goes.
So
That's-
it's gonna be a repeat of the 7 minutes of terror.
It is, it's gonna be a lot like that. Uh-huh. In fact, some of the talks I was listening to, they're like, if you want people to know what it's like, show them that 7 minutes of terror video. They keep referring back to that. Yeah.
So once it lands, it can't move, it has to see
it's a
where it's gonna
rover.
land
It's a rover.
before it actually lands.
It's a rover. It's a rover.
It's a rover.
So once it actually gets to the ground,
I mean, like, it could land on this uneven terrain if it wants to, and then it can move itself.
it would not want to land on the uneven terrain.
No.
No, it would slip down those hills and not survive. So it's gonna try and land on the flat part down over here, not over here. If it sees it's landing here, it diverts itself over to here. Yeah.
When is the guesstimated plan for manned flight to Mars? What is the date that would take place?
That's a good question. Can we come back to that later in the presentation?
That thing is
Because I do have some slides
that
dedicated
thing
to
is
the topic.
hanging from it has to land somewhere, right? It's blowing the rockets.
Right, so another part of it, and this happened with Curiosity, is as soon as it drops, as soon as the gantry ropes they sever themselves, then the rocket's fired off to the side. So it can't crash land
Goes and
on top of the
crashes-
rover. Yeah,
Crashes somewhere else.
crashes somewhere. They intentionally say, okay, now go this way because we're no longer tethered.
Crashing somewhere else on the planet?
Somewhere else on Mars, yeah.
Krissie, on that 1 gigabyte photo, they showed the top of the Curiosity, and they showed those severed cables.
Yeah.
I was really amazed to see that they did that. I don't know, the explosive things that do
I
that.
wasn't sure how I saw the same thing. I was like, that's so cool. Because you can see it was a really clean cut in 3 different places.
Scissors.
Yeah, so I'm not sure what the mechanism is for that. Yeah.
More bouncing balls.
And then once it lands, they're hoping it'll go an entire whopping 20 kilometers. Its top cruising speed is 0.01 miles per hour. It has a lot of really interesting instruments on board. We'll talk about a few of them. It's qualified for 1.5 years of Martian time. So hopefully it lasts that long. We'll see. If they actually make it to the planet, almost always those Mars missions outlast by quite a while their qualified time. But that's a lot of ifs. There's a lot of variables between now, when it hasn't even launched yet, to a year from now, landing on Mars successfully. And hopefully we'll have those samples all cached and ready on surface for a future date. So here's one diagram. Gosh, they get so cutesy with these. For a split second, I thought about like printing out what all these acronyms stood for, and then I just, no. Sorry, I don't remember what Sherlock stands for. Don't worry, the Sherlock sensor has a Watson camera next to it, it's true. Pixel, Meta, I mean, it's just a moxie. We'll talk about these. This one shows you a little bit better what the actual rover looks like. So the Pixel camera, here's what's exciting about these two things, Sherlock and Pixel. So Sherlock and Pixel are two different, respectively spectrometers, but what's really great about these two is that not only do they tell you what chemicals are there, but they're going to be using subsurface imaging, so you can see the composition, but also the texture at the same time. So it's one thing to know which chemicals are there, but it's another to know geologically how they're laid out, right? Are they all mixed together? Are they layered? How are they layered? Are they stratified? These are things geologists really care about. They just, when you talk to a geologist, they don't want to know that this mountain has these minerals in it. They want to know where those minerals are, right? How are they juxtaposed? Wow, that light does that make people crazy over there going on and on? What's that?
Yeah.
It is.
Sorry.
It's not your fault.
Got a BB gun?
Yeah.
So that's what's exciting to geologists and astrobiologists, because astrobiologists who are looking for signs of life, they want to know, well, if these minerals are arranged this way or that, I'll show you in an image later, but if they're arranged this way or that way, that can only happen through a biological process. So they're hoping to see something like that. The mass cam, this camera here, is pretty similar to ones they've had in the past. It has a big robotic arm and actually a smaller robotic arm to pull all the samples out of here and attach them to the robotic arm and take them back in. And then the MOXIE is this instrument that they hope will be able to take carbon dioxide and convert it into oxygen. And if this system they put in place works, awesome, because then we already know we can do that if we're going to send people there. There's a lot of carbon dioxide and humans need a lot of oxygen. So hopefully the CO2 to O2 converter works on that one. You can see it's a consortium. It's not all American instruments, Spanish instruments, French, all kinds of different people all put their instruments on our things.
I think suppose they power the wheels. Is there an electric motor on each one?
Yeah.
Is that what it is?
Yeah, they all operate independently. And they're much tougher alloy this time around. Yeah, that was one of the big redesigns.
Okay.
And as it says here, I don't know, it's hard to read this, I know, I'm sorry. It is a plutonium power source. So there you go. And one thing is the chopper. The chopper Scout is called Scout. They built this adorable little helicopter. Again, this is another proof of concept situation. They're not expecting it to do much. It should have 5 very short flights if it works. And it was a real challenge to build because Mars' atmosphere is much thinner than Earth's atmosphere, about 1%. So obviously it's hard to get lift when there's no air.
Yeah.
It's a real challenge. So I do have a quick little video about that one.
Can we fly at Mars? That has been a question for a long time. This is a huge milestone for us. But really our job isn't done until we see the same test flight being performed at Mars.
So it's cute and hopefully it works. This is not one where they're like, it's gonna be awesome. This is definitely one where when you talk to the scientists who are working on it and all the talks they give, they're like, yeah, we hope it comes together like we think it will. Because it is so iffy. I mean, flying a helicopter with, like it said, 1% of Earth's atmosphere and 40% of the gravity is a challenge. It's totally different from Earth environment, and Martian weather can be really fickle. 70-mile-an-hour winds can just whip out of nowhere. kinds of stuff.
There's obviously a camera on
Yes, there's a camera on it. We'll take a lot of images, I mean, if it works. The plane takes images, relays them back to the Perseverance rover, who then sends it back to us via the Deep Space Network, yeah. So let's see, going back to here, the caching system is all tucked in here, like I said. The core, there's actually a bunch of different drill bits in here as well. So this little tiny arm, you can't see it very well, picks out first an abrasion tool that it attaches to the arm, drills away a little the surface of the rock, then it attaches another piece that will drill in and take a core sample. So this is an example in one of the talks that do you ever call in on those Night Sky Network talks? They're really cool. You should. Anyway, this is one where a geologist who's working for NASA on this mission was talking about a specific structure of elements you could see on Mars, but on Earth when they're arranged like this. And he called it Mickey Mouse ears stromatolite. He said that's indicative of a certain way that ponds found layers over time. At the edge of a lake, you would see a formation like this because there's ponds found in that as it dries and interacts, and then over time creates this weird buckling phenomenon. So that's why they want to use all these different, they want to take core samples to see that layering eventually, but also hopefully using Sherlock and Pixel, be able to map in 3 dimensions, right, where all these different elements are. So here's, there's a couple different diagrams here of the caching system. It has a coring drill, the instruments to look at all the stuff. It kind of here's the little arm here, pulls things out and attaches them and deattaches them, puts the samples. This is the carousel where all the core samples go. Tucked away there. So there's this was a sample they did obviously here on Earth. It hasn't gotten to Mars yet. Gotta make sure we're really clear on this one. It's 5 centimeters long. The samples should weigh approximately 15 grams once they're back here on Earth. And they're hermetically sealed. Not only that, but you can see it says witnesses. They want to make sure, if they're ever going to come back to Earth, that we totally understand the conditions in which they were sealed up on Mars. So what they also do is they take a little sample of the Martian atmosphere to go with it because they want to make sure that they can cancel out anything that might be, for example, outgassing from the rover itself, or chemical remnants from the landing propulsion system, or some inadvertent organic or inorganic Earth stuff that somehow tagged along. That's what witnessing is in this context. It's just taking a sample of everything around your core sample 2, so you can then kind of cancel out stuff you need to make sure you know exactly what's happening. And it's all sealed up and hopefully remains intact and untouched until it makes it back to Earth. So we could get an absolutely pure, completely uncontaminated Martian sample back here on Earth. That would be really cool. Groundbreaking, obviously. We've never done anything like that. We've had pieces of Mars land on Earth, but of course they have to go through all of Earth's atmosphere to get there and then land on the surface of the Earth. So something that's never touched the Earth or its atmosphere directly would be super cool. And the plan is not to take samples all in one spot, but to find an optimal spot where they want to have their cache dropped off, right? So the rover will look for its ideal spot, and then it will take different samples here, and then take it here. Then it comes up here, takes a sample, goes back to here. Then it comes over here, takes a sample, and goes back over there. So that eventually they're all cached together in one spot. The primary mission is, of course, those 20 kilometers from here to approximately here. But if it has an extended mission to go further up the side of the crater, they'll try and do that. So this astrobiologist that what I was listening to was talking about, like, ideally, this is what we get. It would be so exciting. We get regolith, we get delta deposits, we have the olivine from the floor of what they think used to be a lake, channel deposits, all these different places that here on Earth would give you totally different geologic samples. totally different mineral compositions and structures. So the plan is they will be able to take all these different samples. We'll see. And then the eventual plan would be that a secondary mission would do this. There would be some sort of orbiter that would orbit Mars with the plan of returning to Earth first. And then there would be some sort of lander that would come, pick up the samples, and then launch this tiny little capsule that would rendezvous with the orbiter that would then eventually return to Earth. Right, it's ambitious, they know it's ambitious. They're not talking about it like it's a super serious, definitely gonna have a plan. They're talking about it in a, we really hope someone in Congress falls in love with this idea kind of a way. So speaking of the landing site, let's take a look. This is a topographical map of Mars that probably people are, if you know a lot about Mars, you've looked at it before. Obviously, these are the areas of high elevation. Well, really high elevation, The blue is lower areas of elevation, so you can see a lake here and what was probably, possibly an ancient ocean on Mars. And they want to land here at Jezero Crater. Let's look at that inset. So as we're looking at it, you can see this is like, the lower elevation area with all these higher elevations, and they want to put themselves right there because it's so geometrically interesting. The landing ellipse, of course, is where they're hoping to land, somewhere in there. But you can see from these images, it looks a lot like you might see looking at a channel deposit area here on Earth. You can see the different minerals and this outpouring. So they're really hoping that as they study this, they'll see something similar to areas on Earth where there have been water that's flowing from high elevation to a channel to suddenly stopping when it hits a relatively still water like an ocean or a lake. That's what they're hoping to see. Another quick video.
This flyover was produced from NASA images taken from orbit. The blue circle indicates the area the rover will likely land. The arcing hills in the center, about 1,600 feet high, are the rim of Jezero Crater. The central goal of Mars 2020 is to learn whether life ever existed on Mars. It's too cold and dry for life to exist on the Martian surface today. But after Jezero Crater formed billions of years ago, water filled it to form a deep lake, about the same size as Lake Tahoe. Eventually, as Mars climate changed, Lake Jezero dried up, and surface water disappeared from the planet. An ancient lake is a fantastic place to pursue our goal of looking for possible Martian life. On Earth, lakes are filled with living creatures. Evidence of that life is often preserved in the mud and sand deposited on the bottom of the lake. So, we use the rover's instruments to explore the rocks of the ancient lake bed. Here we can see evidence of the former lake. The canyon cutting through the crater rim was carved by a river. As the water entered the lake, it slowed and dropped the sand and mud it was carrying to form the fan-shaped delta. The white line is a path the rover might follow in its first 2 years, called the prime mission. During this period, we use the rover science instruments to analyze the lake sediments. After we explore the delta, we hope to investigate the shoreline of the former lake. To get there, we have to traverse around a sea of modern sand dunes. From this perspective, you can see former shorelines curving around a headland. We can picture waves in Lake Jezero beating on a sandy beach. And finally, we will press on to the crater rim. Jezero Crater formed when a large object collided with Mars, excavating rocks from deep in the Martian crust, exposing them in the rim for us to study. These rocks would have been hot shortly after the impact, and may have hosted hot springs. Deposits from these springs would be another target in our search for possible ancient life on Mars.
Krissie,
Yeah.
do you think this crater was formed when there was still water on Mars?
Do I think or do they think?
Do-
They think it formed after, but I think that we're not totally sure about the geologic timetable of water on Mars, especially because we thought there was lots of water on it and then there wasn't, and then there is no water, but now we've seen pretty clear evidence of actual, like, current geomorphology that seems really indicative of water, that occasionally seems some of that subsurface water ice actually melts and then flows somewhere and then gets back absorbed into the soil, or sublimates. Yeah. Question?
What is the range of the rover and how many miles does this traverse or trip to do all these sites, to visit these sites? How long will it take, and how fast does the rover go?
The cruising speed of the rover is 0.01 miles per hour, and its primary mission traverse range is 20 kilometers, that's what they're hoping for.
And after that, the even with solar panels, the batteries would not be.
No, the batteries would be great, hopefully. That's just the primary mission. They're saying, we're saying it's built for sure to last a year and a half of Martian years. But if it lands successfully, it will probably last a lot longer. The Curiosity rover only had a 2-year lifespan, and that arrived in 2012 and is still going strong 8 years later. So,
0.01 miles an hour, that's 1/100th of a mile, and about 50 feet.
yeah, it's not, they're not built for speed. We'll say that.
Less than a foot per second. Per
Yeah,
minute, I mean.
they're moving real slow. They're not trying to get anywhere in a hurry, right? They have years to get there, and it's more important to be steady and stable and have the scientific instruments on board that are, the instruments themselves are relatively delicate. So there's no reason to go fast, especially because everything they wanted, they picked a landing site where everything they want is in pretty close range, hopefully, if landing goes successfully.
You said there were like 70-mile-an-hour winds unannounced to come up. This vehicle will heck, you see trucks flying over at El Cajon all the time?
Well, the atmosphere is thinner, so there's that. But so far, we haven't had any rovers took over, and this one's the biggest time it's only over the Senate. So,
So if you have 70-mile-an-hour winds and the atmospheric pressure is 1% of Earth, then there's not much force, there's not much drag.
right.
No, you can find an article, I think it's a NASA article about the, how little you will actually feel a 70-mile-an-hour wind on Mars, because of that, because the fluid density is so low. And all the catastrophes you saw in the movie The Martian, just wouldn't happen.
Yeah, I mean, basically, all those high winds do is dust the solar panels.
Yeah, you won't blow a rocket over, or you wouldn't blow away the guy's shelter over his potatoes.
Yeah, it just clears over all the dust on the panels. People were really worried about that with the first rover, the Sojourner. They were super worried that the wind would kick up and the solar panels would be caked in dirt, but it turns out the winds actually just clean them off for us, for the most part. Yeah.
In recent times, you had that big dust storm that covered the whole planet.
Yeah.
Okay, so what would that do to the new vehicles going up and also that helicopter? I mean, would that just?
I mean, the helicopter obviously would not try and fly in a dust storm like that. I don't think the helicopter is built to last very long.
Right.
The biggest problem with dust storms is that sunlight can't get through. If they last a really long time, that's the only real hazard, is that the batteries drain because they can't get any solar power because the sunlight can't get through all the dust. But most of the time, the dust storms don't last long enough for that to be a real concern. That is, although I will say possibly what killed the Opportunity rover. Yeah, Chuck?
But this one has the RTG, the plutonium power.
Right, it's
source, so that would
plutonium
help.
powered with the solar panels, so hopefully that is definitely not it. Keep it going.
The plutonium's killing all the Martians.
We hope not, but yeah, I mean, it's a real concern. They are definitely following all the safety protocols from all the international agreements on not contaminating stuff. But people are people, and if there's one thing we know from reading every headline ever for the last few weeks, there's not much you can do against something really aggressive. And there's no sinks to wash your hands on Mars. Okay, so that's Mars 2020. I have like 15 minutes left of our time. So I want to talk about some other Mars missions. Obviously, NASA has a huge budget for EPO, Education and Public Outreach, so they have a ton of materials online. And since I am a solar system ambassador, I get to get on the NASA telecons with all the NASA scientists. So I have way more information about Mars 2020 than some of these other missions. And that's not because they aren't interesting. it's mostly because they have smaller budgets for that sort of thing. Or also one of them's from China. So, that's another reason. But let's talk about ExoMars. This is a European Space Agency / Roscosmos, that's the Russian Space Agency joint mission. And it's a two-part mission. In 2016, they launched a lander and an orbiter. The orbiter, the trace gas orbiter, was successful and in orbit. It was great. The lander did not. There was a data glitch on the Schiaparelli lander. It caused the parachute to deploy too early, and it did not survive. But they were already planning a second rover. The first one was more of a proof of concept because they had never landed a rover before. So this was successfully. So the first one was like a practice, let's see if it works. And the second one they named the Rosalind Franklin, after of course the scientist that worked a lot with DNA, super famous scientist. They're nice. They name their stuff after famous scientists. Here in America, we have like naming contests, and you get things like Bodie McBoatface. That's a good reason to not have Rovey McRoveface, right? Just pick it yourself. Don't let the people do it. We're not good at picking things lately. So anyway, it's launching. All these are launching this July because that's the window, right? That's when Mars and Earth are in the optimal locations in their orbits. So these are all launching. Although ExoMars is having some issues with its parachute. They were testing it several months ago and it kept tearing. So if they can't get it cleared by the end of this month, they'll probably be delayed. And of course, they'll be delayed till 26 months from now, into like a late 2022 launch for that. But you have a fun video. They made at least one video for us, so we can see what theirs is going to look like. Oh, good YouTube ads. Belarus/Russia, yeah. So hopefully that was successful, but like I said, they've been having some real issues with the parachute. So that may end up being more of a 2022 situation. We'll hope for the best for them. China is trying to launch the Mars Global Remote Sensing Orbiter and Small Rover mission called HX-1. In Mandarin, Huanjing means Mars, so HX-1. But there is not a lot of data coming out of this one, and as recently as a few weeks ago, they still haven't decided on the landing location. So I think this is a real soft 2020 launch. I'm not sure how much the current health situation there is helping. People are quarantined, they're probably not getting a lot of work done on this, at least collaboratively. Although, good news, clean room environment, right?
Yeah.
So, who knows? It's, there's not a lot of information on this one. I'm not sure if that's because they don't want us to know or they don't have a lot to tell us. Also because I can't read Mandarin, so I couldn't Google it in Chinese. But here's a little video. How quick is this one? We're almost at 10.
China plans to launch mission to Mars next year. China is planning to send a space probe to Mars next year. China's Mars 2020 mission will be launched on the Long March 5 carrier rocket from the Wenchang spacecraft launch site in Hainan province. The lander, along with an orbiter and a rover, will be deployed to the Red Planet. The mission is being called the Mars Global Remote Sensing Orbiter and Small Rover, or HX-1. The lander is designed to operate for 3 Martian months. The lander will touch down on the northern hemisphere of Mars, according to the State Council of the People's Republic of China's website. The lander will contain a rover that has 6 wheels and 4 solar panels and will be able to explore Mars by itself. The rover will contain a remote sensing camera as well as a ground-penetrating radar and is expected to collect Martian soil and bring it back to Earth by 2030, according to Futurism.com. The news comes after the success of China's moon mission earlier this month. China's lunar probe made history as the first spacecraft to ever touch down on the far side of the moon. The spacecraft took off in December last year with a lander and a rover. It also took along cotton seeds and potato seeds to see if they would be able to grow in the low-gravity environment. The cotton seeds had since sprouted, but unfortunately the cotton plants didn't make it, with the temperatures being too low to survive, the Independent reports. The lander analyzed the far side of the moon using various features, including a landing camera and a terrain camera, and sent back images to our planet via Kuei-Chao, a relay satellite.
So, there you have that. I wouldn't count China out. Even if this one doesn't launch this time around, they really did do some really great work with that lunar lander. That was really cool. And then there's an Emirati mission coming out. The United Arab Emirates are really excited about their orbiter. And they have this all set to coincide with the 50th anniversary of their nation. And for them, they call it Hope because, first of all, they consider themselves a little bit different from other countries in the Middle East, and they want to show it's not all about protesting and ISIS. This is from their website. I'm not paraphrasing. That's like what they're trying to tell us. So what's interesting about them, the whole mission is this orbiter, which is going to be really cool, but also they're really putting a lot of thought into their social messaging. The mission is 34%, the mission team is 34% women, and 50% of the leadership roles are women, and 90% of the team members are 35 and under. So they're definitely sending this, like, young, diverse, we're doing it, science message, which I can totally get behind, and I think it sounds really great. And one of the things this is going to do is try to figure out what is going on with Mars water, right? Because it had a lot of water and then it disappeared, and we're not totally sure how that happens, like the actual physical and chemical processes. It gets, basically it just like disappears into space. But we're not sure what the mechanism is for that totally. So this orbiter is hopefully going to be giving us some more answers to that. Because if we're trying to inhabit Mars and we need water, we need to keep water there, right? So that's a cool one. Launching in July, they all are. And then, let's see. Oh yeah, we won't watch their video, but it is really cool. India has a mission that will be launching no sooner than 2022. It's a follow-up to their Mars Orbiter mission of 2014. So just a few Mars cycles back. They have Mars Orbiter Mission 2 that they'll be launching. There's not a lot of details on that one yet. But the first one is still working, so great job, India. And then, let's not forget Elon Musk. He's got big plans, and he's got big money, and he wants to send people to Mars right away. If he could do it tomorrow, he would. He's building 1,000 spaceships a day. So he says in a recent tweet from just several days ago, he would have a prototype ready in 3 months of the SpaceX Starship that has reusable, not just the ship itself, but also the rockets. That's a big deal. And SpaceX has had a lot of success with that. They've had a very recent setback. If anyone saw the news on Friday, one of their rockets, a lot of news sources say it exploded, but technically it imploded. And he has promised that super rich Japanese guy that he would have him in lunar orbit by 2023. And he has in the past tweeted he wants to have people on Mars by 2024, but I don't think that is anything realistic. And I really have a hard time considering someone's personal tweets news. I know, I need to get with the times, but I'm just too old to consider that a reliable source of factual information. According to him, he sees SpaceX transporting up to 1 million people to Mars by 2050. NASA's ultimate goal for people on Mars was, of course, by they wanted to have people there. Right now, they're saying people on the moon by 2024. Mike Pence recently said, no matter what it takes, we're going to get people, Americans will be back on the moon by 2024. With the plan that that's a stopping point and people will then be on Mars by 2030. I think that is optimistic at best, and that number could sway in either direction depending on how the government chooses to spend its money, if it's going to be a NASA thing. We'll see. So there are plans to get people to the moon and then to Mars, but there's no one is saying, book your ticket now. Well, Elon Musk will love you to book your ticket now, but I wouldn't trust him at this point. So let's bid goodbye to the red planet. The sun's setting on Mars. Any questions? Who has questions? Yeah, Mars.
So to begin with, to inhabit Mars,
Yeah.
you have a plethora of roadblocks ahead of you. You've got,
Yes.
you've got radiation, you've got
Yeah.
gamma rays, you've got zero gravity.
Mhm.
How is this all going to be, addressed to get the folks there safely up there?
That is one of the biggest criticisms of the SpaceX missions, is that it seems like they are not actually taking radiation safety as much of a priority as they should be, as most people think they should. So it's a real concern, yeah. Mars doesn't have a magnetic field like we do, so.
I'm talking about en route from Earth.
Yeah, as long as you are not protected by a magnetic field, you're gonna have lots of issues with radiation. You're gonna have, like you said, gamma radiation, alter your DNA. It's a real thing. So, yeah, we don't have 100% of the solutions for that one yet. Great question. Yeah.
Will this space program be diversified ethnically compared to like the Mercury? Or is just little white people from Ohio that got to fly the
From your mouth to God's ears. NASA's really making an effort, and they have already said that the next time an American walks on the moon will be a woman. They've committed to that for Artemis mission.
About 50 years too late.
Okay, good.
Seen it change.
Yeah, it is a goal of NASA's for sure, whether that's like because they feel like it's right in their heart, or they know that that's really good optics. Either way, we'll take the win, right? Yeah.
You showed this 26-month lag as the Earth and Mars are in closer conjunction.
Yeah.
To take advantage of that. Does that happen at the same, is it a seasonal progression? I mean, does it happen at the same time? Would the season be the same on Mars when they get there?
No, so Mars does have seasons,
Yes.
like Earth's seasons, but because the cycle 26 months isn't quite lined up with theirs or ours. Yeah, there's different
Okay.
seasons, and that does change landing sites, for example. You don't want to land at the North Pole once the North Pole's
Exactly.
winter.
Yeah.
Yeah. Although a lot of the missions are more equatorial, but sometimes they want to look at the ice. The Mars Polar Lander was supposed to be looking at ISA. So yeah, you have to consider which 26-month cycle you want to be at. If
Yes.
you want to land at a specific spot, or just decide to go to the other pole.
So that does affect their planning to a certain extent.
To a certain extent, depending on if they're trying for something more equatorial. If it's more around the equator of Mars, then the temperatures are slightly more temperate. I mean, temperatures on Mars are a lot colder than Earth. If you were at the equator on a super nice summer Martian day, it's 70 degrees. But it can get like negative 170 if you're at the poles in the wintertime at night. So temperature is a consideration. Yeah.
Just found out recently that it does have evening glow, so how does that affect the weather, or, does that have been?
I'm not sure. Yeah. I don't know, Martin, I'm sorry. Yeah, Chuck?
Okay, so the new wheels look like they were solid, and in the past, Caltech always put the little holes in it so that it would do the Morse code for California Institute of Technology as they drove along the surface. Is that kind of getting
I think it's getting old.
Yeah.
Yeah, it was cute, right? There's a lot more ways you can insert secret messages now, right? You put some sort of nanobot messenger that flies in somebody's ear and says, Caltech, Caltech, Caltech. Yeah, any other questions? All right, well, thank you so much. Oh, what, I see one more. Yeah.
Given that the whole issue of radiation in spacecraft was risen, have any of the astronauts that have traveled, have they developed any weird cancers?
Not that we know of yet.
Not that yeah.
And there are radiation shielded portions of the space station when there's like a coronal mass ejection or there's a lot of solar activity. They go to a shielded part of the space station when it's going to be something they know is incoming. Yeah. Good question. All right. Well, thank you.
You did very good here. Everything we've ever wanted to know about Mars and the future, and here you go, a little stipend from us to you. One of our priceless porcelain cups. They pay big money though, non-members for this, don't they? You get to start with the cheese puffs and the donuts if you want to leave the way.
My kids are selling Girl Scout cookies, so I'm going to have to say no. I've had way too many. Anyone wants to order any cookies, it's the last weekend. Come on.
What's wrong with you? You did good, thank you.
I'm returning this check.
See you later, Colin.
They're adorable and hilarious. I love Girl Scouts. They're 7 and 9. They're little still. Still cool.